KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name's Pam Halstead. Welcome to Homework Hotline. My name's Pam Halstead, and I taught science at Fortuna High School.
My name is Amy Taylor, and I teach 7th and 8th grade math at Sunnybury Middle School in Arcata.
Yes, yay! We're so glad that you guys have joined us.
Yes.
Amy is our host today, and I'm going to try to help her, or
Yes.
I'm going to show her how I would solve something,
Yes.
and who knows if it'll be right, because I didn't prepare, and so that's good. Anyway, that'll help.
Yeah, and we have the colors, because November,
That's
and
right.
then all the blues and browns and all the
Yes,
fun greens,
yes.
and yay, it's fall for sure, and
it
November
is. Oh my gosh,
fun.
November 2nd, and heck, we've been having a lot of rain, which is awesome.
Yes.
Really nice.
Yes, it's helpful.
It's very good. Yeah. So anyway, that's going to continue.
Yeah, so at my school we used this Savas Realized, and they had a test, and I thought, well, it's a nice way to kind of overall all solving equations, which you need for math and science. I'm teaching in 8th grade, but really all the grades. You know, you do these systems of equations eventually, and so yeah, I just thought we'd work on, and within it, I review topics like integers, positives, negatives, simplifying expressions. We have some fractions, inverse operations. So there's just so many things embedded in it, and I thought it was a good cover,
Great.
especially this time of year. So.
Is there more than one way to solve these equations?
Oh, there's infinite ways to solve. I
Oh,
just try
sweet.
to give.
No,
I just
that's
try
good.
to give ideas
I know
in
there's
terms
a standard
of,
way
yeah.
too, though. I mean, that will be
No,
helpful.
yeah,
Maybe
I'll
helpful.
just start with it, and then I'll have you help me
Okay.
after I. But
Excellent.
anyways, then we get through as much as we can, and we'll cover a lot.
Okay.
So I typically, when I solve equations, I'm going to start with, I'm going to color up here. So Gemma, it's kind of the new PEMDAS, because PEMDAS people only do parentheses, and then they forget and they accidentally do multiply before divide. So I say Gemma, grouping symbol, exponent, multiply, divide, left to right, add, subtract, left to right. There's so much embedded in this, I'm just going to... But I tell the kids to do Gemma backwards, meaning first you're undoing, we're peeling off the layers when we're solving for this isolated variable x, solving equations. So first we're going to add, subtract. So if I was to add, subtract, what would I do for that first step?
I would add to both sides of the equation 6, because we got a -6 there.
Yes.
That's exactly.
And the reason we want to do inverse is we get these things called identities, because the inverse of -6 is +6. That gives us our identity 0, and we add 0, that doesn't change it. And the reason we have to add 6 to both sides, I always tell students, think of like a balance. If you remove, or if you add 6 pounds to one side of a balance, and then you go ahead and you don't add it to the other, your balance is not actually going to be even. So like this, we got to balance it. It's actually called the addition property of equality. It literally is making it equal.
That's so cool, because in chemistry it's the same kind of thing. You have reactants, which you put into an equation or into a reaction on the left, and you have products on the right, and you can't do one thing. You can't add reactants and not change the product.
It would not,
and vice versa. It would not work.
Balancing for science or a scale. And then do you remember how to turn fractions that are mixed into what we call improper? I don't like them to be called improper. I like them common fractions, but where we have a number on the top and the number on the bottom.
You make the denominator the same as...
Yeah, I want to turn 6 of these 6. Basically, I want 6 groups of 6.
Yeah.
And then I add that 5.
Okay.
But the reason we do that is then it can be easier in terms of now I have 6 groups of 6 is 36. Yeah, plus 5.
Okay.
41/6, because then I'm now to my multiply, divide, and then what I do with my students, we need to know that fractions are divide signs. Everyone wants the divide signs for so long to be this, and we don't want to use that anymore. Not that that's wrong, but then when we see this, we don't know what's divide, and a fraction is literally just a division sign. It's not like a fraction sign, division.
Yeah.
So the inverse of division is?
The inverse of division is multiplication.
Yeah, so I multiply. There's my balancing both sides. Mm-hmm. And now the nice thing is, sometimes I say at this point you can use a calculator, but we don't necessarily need to. We want to start off not, just time-wise. But do you see anything that could kind of simplify early? here with the numerator and denominator?
The numerator, denominator, 6, 2, change 6 to a 2 and 3 to a 1.
Yeah, so 3 divided by 3 is 1 and 6 divided by 3 is 2. And the reason I tell students to do that is, isn't it easier to manipulate smaller numbers? Yeah. You're not making it smaller. We used to say reduce. We're not reducing. It's the same number. It's just we can simplify it. We have smaller numbers to manipulate, which is easier. And the reason we can do that is something called the commutative property. You can multiply in any order, so it doesn't matter if the 3 is above the 6, because 3 times 2 equals 2 times 3, commutative property. So many things behind all of these concepts. So then we just have 41 halves. And actually, we don't need to change that. If we're not applying to graphing, baking, money, etc., we don't, 41 halves is just as good as any other number. For some reason, it's been called improper. There's nothing wrong with it. It is literally 41 halves. We could say 20 and a half. We could put in a decimal, 20.5. There's just no reason to. So I'm going to leave this because that is it's not proper fraction, but it's proper math. And there's no reason to change it if we're not applying. Cool. All right, we're going to do another one.
Yay.
So Gemma backwards.
Okay.
So first we're going to add, subtract. So what should I do first?
So you should add a 6 to both sides.
And I like this one because now we're dealing with negative and positive numbers. And we're still balancing inverse. But we have 1/10 y equals, and what is negative 16 plus 6?
That is negative 10.
Yeah, and some people have these rules that are like negative times positive. We just think of it logically. I kind of think of money. If like I owe someone $16 and I pay 6, I still owe them 10. I kind of sometimes with food or money, I feel like if you can convert things, we all have food and money in our lives, so it helps. And then you have extra negative 10, or you would have extra debt. So anyway, and then then we're on to the second step, which is the last step. Which is the
multiplication, division.
And so what would be inverse here?
Now we multiply both sides by 10.
Yep. Okay. And then there's my balancing. My inverse when I multiply divide is not 0, it is 1, because 1 is the multiplicative identity, but we do inverses to get identities. And then y equals?
Y equals negative 10 times 10, and 10 times 10 is 100?
Yeah. And then this is where I talk to students, because now we've got this negative. So I just talked to you about negative 16 plus 6. Well, then why is this?
Yes.
But when we're in multiply divide, the negative actually is just opposite. So we always have these positive numbers. But what if you owe? Oh, I owe you 3 bushels of something, or whatever you owe.
Right.
So then that means
totally makes
we
sense.
need opposite. So now we're in
multiply.
multiply.
You have 10 negative 10s.
Yeah, so we have opposite of a positive, or we're bumping from here to here. Here's my positive 10, now I have negative 10. That's going to get me to negative 100.
So that's why the negative doesn't trump really the positive. It's just telling you how many of those negative things you have.
Yeah, exactly.
Yeah,
and so it's hard because students want to all mix it, and it's like, no, here we're counting, like counting on our fingers, and here we're multiplying. So we have these opposite situations that they've built in. Yes.
Okay, cool.
All right, cool. Next. Yes. I have a word problem. It's a little fuzzy. Sorry. Okay. Mirko went to a sporting event with some friends. They bought 3 snacks of equal price and a drink that cost $4.41. Write an equation to represent the total cost T and the cost S of each snack bought, and how much did each snack cost if they spent $22.59. So we can just try to figure it out. You can just tell me any.
Okay, can I start with equals 22.59?
Yeah, yes, this is what we want to do. No, that's anything. Start with anything.
Yes.
That's just like, what do we do? That's what I tell students. Try to think of it logically. Okay, wait, I have this whole amount equals 20. Yeah.
Okay.
Anything else? And if you can't,
write an equation to represent the total cost T and the cost of each S,
And this is going to be my T. So that is my total cost. So we're good.
Okay, good. We're good on that. Okay.
Yes.
So that is your T, but we have to have T equals somewhere, right? Are we solving for something?
Yeah, so we have 3 snacks.
3 snacks and a drink. Write an equation to represent the total cost and the cost S of each snack bought. Okay. So S of each snack bought.
So we have 3 snacks.
We have 3
for
snacks
both of them.
and S. Okay.
And then we also have what else? We have one more thing we're paying for.
Oh, we're paying for the drinks. That's $4.41.
Yep, and that's the whole equation.
Oh, cool.
So if they wanted you, but you see how the logic, how Pam did that, like, oh, wait, what's my total? That's what you're equal. And that's what we want to do. We want to figure, oh, I have these 3 stacks. Oh, wait, I have this drink, but we already have the drink price. And that is the whole equation. And then we just do our Gemma backwards like we've been doing. And a lot of times they'll tell you what the variables are. If not, I try to put like S for snack. It tells you that. But I would my brain likes to use whatever letter I'm going to solve for.
Yes.
So I can be like, what? Oh, months or whatever it is. All right, let's try our Gemma backwards. So first we're going to add, subtract.
Okay, so we should subtract 441 to each side.
And logically, why are we removing the 441?
Because it's with the, logically, it's the drinks, and we're trying to solve for this price of the snacks.
Exactly. So we already know this cost, so we're going to remove it from my total cost.
Okay. Good.
It's just so much easier to do logic than it is. Let's see if my math is right. I did do it ahead of time too. Okay, but 1818 looks pretty good.
Okay, good. so we have 3S equals 1818 then?
Yeah, so we have 3 of our snacks. Okay. And now,
we divide.
Yes.
By 3.
Because now we're in multiply, divide. Gemma backwards, and then we divide by 3. Yep.
Yes.
And it actually goes in nicely to that number.
Oh, cool. It does.
Because 3 goes into 18, 3 goes into 18.
Yes.
So what is it?
6.6.
$6 and...
6 cents, yes.
Yes.
$6.06.
For each of my snacks.
Nice.
So it's nice and logical. You're like, oh, what am I removing first? Okay, that makes sense because I already have that. Okay. Yeah, so it's just kind of nice logic.
This is where people have people just freak out when they see
words. They see words.
And they're like, oh no, I
but
can't
if you can when I start to help students, I'm like, what's our context? Are we like buying windows? Are we buying snacks? Is snow? They have ones where snow's building up. Like, what is the context? What are we even doing?
That makes sense.
Because it's harder, it's easier once you actually know what's going on.
Yeah.
All right, so now we're gonna get to a little bit harder, I guess, more steps. But now we're doing Gemma backwards, but we want to get our variables on one side and our numbers on the other. Now, I typically do variables first because students do have trouble remembering to divide by negatives. And so if we can make it not have any negatives attached to the variables, then we will have a better chance of making less simple mistakes.
Okay, so then, with this, so we have more ends on the left and we have less ends on the right.
Perfect.
So we want to subtract the less ends from the more ends, so minus 5n.
That's a perfect explanation. Again, you actually can do 14 inverses, or 4 inverses here, but I try to go in ways that make least simple errors that could occur. So then we have 2n minus 19 equals 7. So we did our add, subtract, inverse, balance, get our identity, and then?
We are going to now add 19 to both sides.
Yep. Okay. So now this is like, we have 3 steps instead of 2 because we have to get our variables together. They're like terms, they're both ends. They could think of nests, like bird nests. I sometimes make them words, so my brain can go, I had 7 bird nests. I subtracted 5 of them. I have 2 nests left.
Yeah.
Like terms are hard for people. These are just terms, 7 and negative 19. They're just terms, but sometimes if you put words to them, it just helps.
Is that why you use sometimes like manipulatives in math?
Yes.
So you like have this many 7 and then you say now take away 5.
And then that's what they would do the algebra tiles. Yes.
Right, okay, algebra tiles.
19 plus 7 is 26. Yeah, this year I probably will do that. It's just harder with people needing to, quarantine and different things this year and spread out. And
where are you at? To know where a person is.
So yeah. Anyway, so then we're on multiply. We did our add, subtract twice. Now we have our multiply, divide.
Okay, so we divide 2 by on both sides.
Yes. It's not liking that.
Oh no. What is?
All right. Well, we divide both sides.
And it's n equals.
N equals 13.
Oh, look, we're at mushrooms. No, we don't want that here. That's good. It's good.
It's okay.
I think we're there.
But you know why? Because this is introduced. This is what we will be doing.
No, here.
Thursday.
Let's do this first. Let's go escape.
Yes,
escaping.
It's all good.
We're escaping.
This is called technology.
No, we're not escaping. Classroom. We're doing this, and then we're just changing down here to this. No, we're not.
To this.
No. Okay, you do. Yes, please assist us.
It's okay. This happens.
It does. Wait, was that it?
It's all good.
That wasn't it.
It's going to be 13.
Okay.
It's all good. This is real life.
This is real life.
No,
exactly.
I mean, in my classroom, I'm like, oh, the power went out. Okay.
Yeah, exactly.
I'm just going to write it on. We'll do one similar.
Yes.
So this is like actually normal.
Sweet.
It's all good.
Why is it going round and round?
Oh,
that's good. Hey, we've seen that before.
You can always do it on paper too.
Yeah, that's right. That's right. Or you can just write on the board, with the things you have.
I can just write on the whiteboard with, I can just like write stuff.
Yes. Okay.
Yeah, it's all good.
Yeah, we've got it. I have this thing.
I am not joking. Like once everything's technology, it's like, oh, Zoom. Or we're at home, Zoom.
Yeah.
Do we want a new version? No.
Not really. Let's try using the old version.
All right, well, we basically got 2n equals 26, and we divided by 2, and we got 13.
13, yes, n equals 13. There we go. That one we can take
next.
all the way down to a number.
Patience is with technology. That's what I learned with all the different tech stuff with Zoom all last year. You just patience.
Yeah, no, it's true.
Okay, you're choosing between 2 health clubs, so we got to think about 2 health clubs. Okay. Club A offers membership for a fee of $7 plus monthly fee of $29. But Club B offers membership for a fee of $42 plus a monthly fee of $22. How many months will the total cost of each health club be the same? And this is helpful depending on, some people want to work out for a reason, some people want to do that for a long period of time, and how many months are you there?
I've got it. So what you're trying to solve for is the total cost. So that is like you're going to
total months, that you want.
After months. After how many months? Oh, months. Okay, got it. Months, monthly fee, monthly. Okay, so how about it equals a certain number of months, which we could call M?
Yeah, that's what I did.
Okay.
So like Club A starts with 7, right?
Yes.
Plus their
Plus
fee.
29, the fee's 29.
And I say month, like that's how many months we'll end up with. That's their
sounds good.
fee per month, and then that equals the other, we want to know when it equals the other club, which
the other club is offers $42 of 22. Wait, $22. Sorry.
Per month.
$42 plus a monthly fee.
And as you see, like if you look at this, you're like, ooh, that's really cheap. But if you're there a long time, that's $29 per month. But here it's like, ooh, that's a lot. But it's going to be cheaper with my monthly fees, and that happens at health clubs, so it's logical. Okay, we're going to do our Gemma backwards.
Okay.
So first we're going to add, subtract our letters,
okay.
our variables.
All right, because the 22M is less than the 29,
Yeah.
we can get rid of 22 from 29. We cannot do the opposite. Okay.
Yeah, we could, but then we're going to end up with 2 negatives.
Too many and oh, it's a mess. Don't make a mess. Try to avoid messes.
All right, then
we do a subtraction of 7 on both sides.
Yes, so we're doing our inverse add, subtract, getting our identity, balancing both sides.
Yes.
So 7M equals 35. And my last step
is to divide by 7.
Gemma backwards, removing layers, divide by 7. And how many months until these 2?
Oh, it looks like 7.
Or 35 divided by
5.
7. 5 months.
Yes.
So if you were only going 5 months, you could do either. But obviously, if you're going less time, you'll want to start with 7. So like 4 months, you don't want to start with a 7. But if you go past 5 months, you want to pay 22 a month instead of 29. And also, with these problems, you don't have to set up an equation. You could like take your 7 and your 42 and start, you would add 29 here, and you would add, 22 here, and you would just keep doing that till they're the same. And if you did that for 5 months, they would have the same amount in both of them, which would be, and we could just do that, what's 29 times 5 plus 7? 45, 10, 11, 12, 13, 14, 145, so $152 if we add 7 to it, 29 times 5. So that's where they'd match, at 152. Thank you. And now you're starting to pay more if you're paying the 29 a month. But I told students, if you want to do it logically too, when you're on a test, you figure this out. Equation, logic, how do we make that be equal? And if there's not like a right way.
And that helps you to figure out where the student is too. So if you're like correcting when I used to correct problems on a chemistry test, I looked at what their work was. Their work was like 2 and their answer was 1 or something, because I want to see where they're going with it.
Yeah, and the more you can actually understand it or use logic.
If you make one math error, you can get the wrong answer.
That's why we try to do the smaller from the big. You try to do these things so you make less of those little errors.
Yes.
So the other thing we haven't done yet is something called combine like terms.
Okay.
And these are terms that are the same. They're both X's, xylophones. This is, we have 5x minus 10x.
Okay, so 5x minus, oh, that's nice. There you go. Yeah, that's where we were. 5x minus 10x. Okay, 5x minus 10x is negative.
Oh, double click it?
Oh, yeah, perfect. Nice. Okay, sweet.
No.
We don't need to auto-save it. 5, okay. Oh, here
Yes,
we go again.
5x minus 10x.
Okay, isn't that negative 5x?
Yes, it is
Okay.
negative 5x.
Okay,
so we
good.
combine
All
like
right.
terms,
Yes.
which is negative 5x
Yes.
plus 18
Yes.
equals negative 3x, and we have a 6.
Yes, we do.
So now we want to get our Gemma, so we combine
Yes.
like terms.
Yes.
I'll put CLT. That is my short for combine
That's good.
like, they're like terms.
Very nice.
And then we are going to...
Make all the x's on the same side.
Yes.
Okay, so if we are going to do that, then we want to put the negative 3 over to the 5, or is that not
Actually,
make
they're
sense?
both negatives.
They're
and we're
both
doing
negatives.
Inverses. So we actually would want to add 5.
Oh, add 5. Okay. Okay.
Yeah, because if we add 3, we'll still get a negative over here.
Okay.
So if we take the
Oh,
bigger
of course,
negative
of course,
and we
yeah.
add 5x,
That makes sense. Cool.
now we have the positive 2x.
Yes.
All right.
Right, nice.
Now-
subtract 6 from both
Subtract
sides.
6 from both sides. But notice they're all different. So if you struggle with negative numbers, I mean, that's why we have to kind of review everything, because
Yeah.
math builds on itself. This is a different problem because of the negatives, because of the
Yes.
combined like terms.
Right.
So 2x equals
12.
And my last step, multiply, divide,
Divide by 2.
and x equals 6.
6, yeah.
And you can always plug it back in to check your answer too, but there's so many
Okay.
different steps.
Nice.
All right.
Cool. I like this variations on the theme.
This is interesting, this problem. So if you do Gemma backwards, you actually can do multiply, divide, and then grouping symbol, meaning this tells you to do the distributive property, but I'll show you it's the same if, see how this 16 on this side and the 4 goes into it nicely? This parenthesis means multiply, so I actually can divide both sides and do multiply first. And then I get x plus 2 is 4. Now I'm in my grouping symbol parenthesis, and then that almost is faster.
Oh, wow, that's
I don't
interesting.
suggest that way unless this number goes into this, because
Oh.
if you have a fraction, now you're manipulating a fraction.
Yeah.
Just do the divide last.
Sounds good.
But that's what they wanted you to do, is distribute, and that's good to review distributive property. So I'm going to show that they actually equal each other, because that's a good thing to do too.
Yes.
Do you remember the distributive property?
Yes, I do. So it's 4x, and then you multiply, but there you go.
Yeah, so if we're distributing, I tell the students, like, what if
Multiplying
a
4.
truck is distributing apples to, like, I don't know, 2 different stores. You're distributing like a distributing truck. This is distributing multiplication because it's parentheses, so I have to distribute that multiplication by 4 to both
Yes.
things within that parentheses.
Yes.
So you said 4 times x is,
I4x
and 4 times 2.
is 8.
Now there's our Gemma backwards to prove that it equals
Yes,
2.
yes.
So what do we do first?
Then we subtract 8 on both sides.
Yep, this is our normal add, subtract first,
Yes.
and then our
And we have
multiply,
4x
divide.
equals 8, and then we divide there by 4, and
Yep.
then we have x equals 2.
So again, this is just 2 ways to do the same exact problem. Here's the distributive property, but there's actually a shortcut. We're still doing
Yeah.
Gemma backwards. We're doing divide and then grouping symbols.
So here's a question:
Yeah.
is there, because Gemma backwards? Why
Yeah.
is there not a something? Oh, was that PEMDAS?
Yeah, so it's PEMDAS backwards, but again, then you only have parentheses. And when people see multiply and then divide, they always want to do the multiply first.
Always the multiply first instead of multiply divide. Okay, well, so why have we not made an acronym or whatever this little shortcut is that is this backwards, so you can go forward with it, like a meg.
Oh, maybe. Well, I think because you want to use order of operations, which
Yeah.
is Gemma. Then when you want to, the reason you say backwards is you want to picture like undoing, like unwrapping a present. You want to picture that undoing. So if you say backwards, you're removing layers to get to that x. So you're removing the add, subtract.
Okay.
You're removing. So then you kind of want to say reverse of the order of operations to understand that one way is just going forward and you're just plugging things in.
Yeah.
But one way you're taking those layers off, so you're removing. So you want that like in your brain.
Okay.
I actually got that from Tammy Masamoto, Gemma.
Nice.
But I liked, yeah, it's way less mistakes happen with that.
Yes,
So.
good. It's easy to remember too.
Oh, this
4
is
letters
another.
versus-
Well, we'll end with this. It's fine.
Okay, cool.
Chartreuse and some friends go to the fair. Chartreuse spends half of her money on rides. She then spends $10 on food. At the end of the day, Chartreuse has $1 remaining. Write an equation to represent this situation and how much money did Chartreuse bring to the fair.
Okay, so we're trying to solve for the money thing.
Yeah,
we're
so she
trying to solve
spends
for
how
money.
much of it first?
She spends half of her money.
I'm going to call it half of her dollars, half of her
dollars.
money.
Okay, that sounds good.
Then how much does she
spends
spend more?
$10 on food.
Spend
plus-
minus
plus-
10 then, right? We're taking her money and we're
Yeah, that's right.
subtracting
We're
10.
moving it. That's right. Good.
And then?
She has $1 at the end of the day.
Yeah, equals 1.
Okay,
Half her
cool.
money, 10 more dollars.
Do we have to write D there? Or
I
no?
put D for, no, this is money. I put D for half her dollars, half her money.
Oh, okay.
Yeah.
Okay.
D dollars, because her money is in dollars.
Right.
So then I do a Gemma backwards, right? So
You
I
Gemma backwards, so you, wait, what am I doing? I've
Add,
lost
subtract.
I think,
Oh, no,
of
it's
course,
fine.
so it's add 10 to both sides.
add, subtract.
False.
Add 10. So now we have half D equals 11. And my last step,
Is that you are going to multiply both sides by 2.
2. Multiply by 2. Inverse of divide is multiply.
Yes.
So D equals.
Equals 22.
So what does
Yay.
the $22 mean?
That means how much money she brought to the fair.
Yeah. Money brought to fair.
Mm-hmm.
Sometimes it's nice to like, what did you even do? And then the more to fair.
Mm-hmm.
And then the more you can say, okay, wait, does this make sense? So she brought $2 to the fair. She spent half of it on rides.
Rides,
Okay,
yeah.
that's 11. She
$10
subtracted the
on food.
$10 on food. Oh, she has 1 left. So just to make it logically make sense.
Oh, yeah, sure. Yeah, when you go backwards that way, yeah.
That's a long one. Ah, we'll see. We got a couple minutes.
Okay.
That's how, when you're doing schoolwork,
So now it's
we'll call
done.
this our last.
4x.
Distribute. -2 times x is,
Negative 2x
and -2 times 5
is
is,
negative, 10, plain old 10.
yeah.
Positive 10.
Then, this will be our finale
Okay.
one. And then we combine like terms on each side.
Yes, we do. So if we added 2 to both
4x
sides.
minus 2x.
4x minus
Oh yeah,
2x is
combine like
2x.
terms.
Got it.
Yes.
Got it, of course.
This was distributive.
Okay, 2x.
It says distributive property.
Yes.
2x, yes. And then on this side, we combine
10.
like terms, which are just regular numbers.
Okay, so we
a
have
different
a
shape.
6 there. It's 6.
-3 plus 9 is 6
Yes.
plus 4x.
4x.
Now our Gemma backwards.
Now we're Gemma backwards. So now we're going to put together, we're going to subtract 2 from both sides.
2x?
2x from both sides.
Minus 2x from both sides. Get our variables to one side.
Yes.
Balance.
Yes. And now we
10
got-
equals 6 plus 2x.
Yes.
And then
Yay, and then we divide by, I subtract 6.
subtract 6. So we got 4 equals 2x. And my last
Yes.
step.
Yeah, last step is divide both sides by 2.
And x equals.
X equals
2. We did our multiply divide. But anyway, that's basically as hard as it gets. You distribute. That's actually forward order of operations. Gemma forwards. You're doing distribute, which is multiply, and then you're doing combine like terms, which is add forward. Then once we're done with that, then we go backwards. We start peeling off our add, subtract twice, and our multiply, divide. So basically, this problem incorporates kind of everything you would do it in kind of typical ways of distribute, combine like terms, and then Gemma backwards. But
Cool.
anyway,
Very nice.
hopefully it helps. I just think like solving equations are so important, and all that, like you said, you do that in science where you're balancing equations, and the more you can do that,
Right.
you get better at it.
Yeah, and the thing to know about things too is sometimes you're ready, your brain is ready to understand things too.
Yes, at
So
different
don't feel-
ages, and don't
yeah.
ever feel bad.
Don't
Yes.
ever feel bad.
Never,
really.
never.
No,
Just
no,
try.
no.
Bye.
Hey,
Thank
great
you.
to- Thank you.